This is the ELEC 1510 Logic Design Lecture 2 Video 1 on binary operations. Most of this information comes from the textbook section 1.2, although it's sort of scattered around some other sections as well. The first thing that I'm going to be talking about is binary addition. So just adding two binary numbers. And this doesn't work any differently than decimal addition. You perform everything exactly the same way. It's just a little different because the only two results that you can ever get are 0 and 1. So basically, when we add two binary numbers together, there are a few possibilities of answers that you can get. If you add 0 plus 0, you're going to get a 0. If you add 1 plus 0, you're going to get a 1. That's the same as adding 0 plus 1, obviously. Then if you add 1 plus 1, now 1 plus 1 is 2, and 2 in binary is 1, 0. So what happened was we get a 0 in the same bit place that the two original 1s were in, and then we have basically a carried 1 into the next place. So that's going to be important when we add longer numbers with more bits together. For example, if we want to add 0101, which corresponds to the decimal number 5, to the number 1011, which corresponds to the decimal number 11. Okay, so we just work from the right side over, so 1 plus 1 is going to be 0 with a carried 1, because 1 plus 1 is 2. So now 1 plus 1 in that place, again, is 0 with a carried 1. Again, 0 with a carried 1, and again, 0 with a carried 1. So we ended up with a 5-bit answer for two 4-bit numbers that were added together. And that makes sense because 5 plus 11 in decimal is 16. We can't represent 16 using 4-bit numbers, so we needed a 5th bit there. Sometimes that's okay if you can have a system that can accommodate for a 5th bit. Sometimes it's not okay. It's going to be either okay or not okay in more of an embedded systems type class. All right, now let's talk about binary subtraction. We're going to cover this in more detail later on in the class too, when we have ways to represent negative numbers. For right now, we're just going to subtract a small positive number from a large positive number, because otherwise we're going to get errors. All that we can represent right now with our number system is positive numbers. So if we subtract a large positive from a small positive, we'll get an error. So we are going to take the number 5 and subtract the number 3 from that. So again, this in decimal is 5. 0011 in decimal is 3. So 5 minus 3. Okay, so we start from the right side and work over. 1 minus 1 is 0. Now in the next place, right here, 0 minus 1, you can't do. So what we need to do is go to the next place and borrow. So if you look at this number as a whole, 1, 0, we can transform that by getting rid of this 1, making that a 0, and then essentially giving ourselves access to two 1s in the smaller, less significant place. So now we have two 1s here. So now we have two 1s minus 1 1 is a single 1. So we used up one of these. Now 0 minus 0 is 0, and 0 minus 0 is 0. So 5 minus 3 equals 0010, which is 2, so that works out. And that's how you perform binary subtraction. This isn't actually how a computer hardware device would perform subtraction, and so we'll talk about later on in the class how it actually does perform subtraction. All right, binary multiplication is another operation that you can do. So let's look at the same numbers that we were using before, 0101, which again is 5 times 0011, which is 3. So we know that 5 times 3 in decimal is going to equal 15. All right, so what you're going to do basically is for every single 1 in the second number here, you're going to write a copy of the first number. But as you get the 1 in the second number shifted 1 bit to the left, you're going to also shift that first number to the left. So let's look at how that works. For this one, there's no shift to the left there, so we're going to just write 0, 1, 0, 1 with no left shift, because that's times 1. Then this number, this 1 here, multiplies the top number by 2, because that's a 2. 1, 0 is a 2. So to multiply a binary number by 2, you shift it over by 1 place. So if we shift 0, 1, 0, 1 over by 1 place, we get 1, 0, 1, 0. Now technically there would be another 0 up here, but we're not going to worry about that one for right now. And now we add up all of those 1s. So 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1. And 1, 1, 1, 1, as we know, is 15. Okay, so multiplication's pretty easy. You just shift copies of the first number for every 1 that's in the second number, and then you just add them all up.